to expose you to what is maybe one of at least the top 5 most useful formulas in mathematics. And if you've seen many of my videos, you know that I'm not a big fan of memorizing things. Let me show you what I'm talking about. It's the quadratic formula. And as you might guess, it is to solve for the roots or the zeros of quadratic equations. So let's speak in very e is equal to 0. You should recognize this. This is a quadratic equation where a, b, and c are, well, a is the coefficient on the x squared term or the second degree term. B is the coefficient on the x term. I know it seems crazy and convoluted and hard for you to memorize right now, but as you get a lot more practice, you'll see that it actually is a pretty reasonable formula to stick in your brain someplace. And you might say, gee, this is a wacky formula. Where did it come from? And in the next video, I'm going to show you where it came from. But I want you to just get used to using it first. But it really just came from completing the square on this equation right there. If you complete the square here, you're actually going to get this solution. And that is the quadratic formula. Equal to 4. B is equal to 4, the coefficient on the x term. And then C is equal to negative 21, the constant term. And let's just plug it in the formula. So what do we get? B squared is 16, right? 4 squared is 16, minus 4 times A, which is 1, times C, which is negative 21. Factor problems right now. So let's scroll down, get some fresh real estate. Let's rewrite the formula again, just so we have, in case we haven't had it memorized yet. X is going to be equal to negative b. Stretch out the radical a little bit. All of that over 2 times a. 2 times a. 2 times over 6. So you might say, gee, this is crazy. What is this silly quadratic formula you're introducing me to, Sal? It's worthless. It just gave me a square root of a negative number. A square root of a negative number. So the b squared, with the b squared minus 4ac, if this term right here is negative, then you're not going to have any real solutions. And let's verify that for ourselves. Let's get our graphing calculator out. Let's graph this. Let's graph this equation right here. So let's get the graph. Y is equal to, that's what I had there before. Let's see, 3x. So that's the equation. We're going to see where it intersects the x-axis. Where does it equal 0? So let me graph it. Let's graph it. Notice, this thing just comes down and then goes back up. Its vertex is sitting here above the x-axis, and it's upward opening. It never intersects the x-axis. So at no point will this expression, will this function do one more example. You can never see enough examples here. And I want to do ones that are, maybe not so obvious to factor. So let's say we get, say, negative 3x squared plus 12x, all of that over 2 times a, over 2 times negative 3. So all of that over negative 6. This is going to be equal to negative 12 plus or minus the square root of, what is this? So negative times a negative, they cancel out. So I have 144. Let's attempt to do that. So let's do a prime factorization of 156. Sometimes this is the hardest part, simplifying the radical. So 156 is the same thing as 2 times 78. 78 is the same thing as 2 times 39, or we could say that's the square root of 2 times 2 times the square root of 39, and this obviously is just going to be the square root of 4, or this is the square root of 2 times 2 is just 2. 2 square roots of 39, if I did that too. So we get 2. And now notice, if this is plus and we use this minus sign, the plus will become negative and the negative will become positive. But it still doesn't matter, right? We could say a minus or a plus, or that's the same thing as plus or minus the square root of 39 over, put into 2 minus the square root of 39 over 3, right? I'm just taking this negative out. Here, the negative and the negative will become a positive, and you get 2 plus the square minus